welcome to the MBS Engineering channel. Today, we are looking at the rotary airlock valve's purpose, function, working principle, capacity calculation and sizing of the rotary airlock valves. We will discuss this in the detailed description given below. The first topic, what is the rotary airlock valve? Next, the second topic is the rotary airlock valve working principle. Next, the third topic is the function of the rotary airlock valve. Next, the fourth topic is the rotary airlock valve capacity calculation. Next, the fifth topic is the rotary airlock valve sizing calculation. Next, we learn about the rotary airlock valve for the baghouse and ESP equipment. The first point is that rotary airlock valves are also called rotary feeders, rotary valves, or rotary airlocks. The second point is that the RAV's primary function is to lock the air and discharge the dust or fine, coarse powder. The third point is that in a baghouse, ESP system, there is negative pressure inside the baghouse. Therefore, if air or gas leaks at the dust outlet point, the dust will not fall down. We offer rotary valves to limit leakage. The fourth point is that the rotor of a rotary valve is a spinning component that controls bulk material flow from upstream to downstream devices. A drive motor linked to the valve rotor powers its rotation. The fifth point is a rotary airlock valve, RAV, locks or prevents the movement of air or gas from one system to the other while maintaining the flow of material through it. In general, a rotary airlock is used to discharge bulk solid materials like coarse fine powder and cake in the chemical process industry, granules in the cement industry. Next, we learn about the working principle of the rotary airlock valve for the baghouse and ESP equipment. The first point is that the vanes, or blades, of a rotary airlock valve rotate during operation. The material being handled enters the pockets through the inlet port before rotating around inside the valve and then exiting through the outlet port. The second point is that in an airlock valve, the air is sealed, locked, between the inlet and outlet ports. This allows the materials to travel downward through the valve from the inlet to the outlet port while restricting the airflow. Material discharges from the rotor with the help of gravity. The third point is that the material is moved continuously in the presence of a constant air pressure between the ports. This pressure or vacuum difference must be maintained within the valve for proper function. The fourth point is that the airlock is achieved by maintaining a tight clearance between the blades and housing. The rotary airlock valve locks the movement of air between the inlet and exit ports while transferring material through them. Hence, RAV acts as a separator between a high-pressure system and a low-pressure system. The fifth point is that the maximum speed limit needs to be less than 35 revolutions per minute. Next, we learn about the function of the rotary airlock valve for the baghouse, ESP, and other equipment. Why it is called rotary airlock valve? Rotary. Due to the presence of the rotor. Airlock. Air movement is locked by the RAV. Valve. It regulates or controls the flow of material through it. The rotary airlock valve has several functionalities, including: the first function is used to control the product flow rate to the required value, fixed or variable. The second function is used to maintain a gas pressure differential between the inlet and outlet. The third function is an explosion barrier. The fourth function is a flame barrier. The fifth function is a process isolator or barrier. Next, we learn about the rotary airlock valve capacity calculation formula. To determine the rotary airlock valve capacity, the rate of conveying, product density, valve efficiency, and rotor speed data are required. The rotary airlock valve capacity formula is. The following equation is used to calculate the rotary airlock valve capacity. Rotary airlock valve capacity C is equal to R divided by D, then A divided by 100, and finally results divided by S. To calculate the rotary airlock valve capacity, divide the rate of conveying by the product density, then divide the result by the valve efficiency, and finally divide that result by the rotor speed. Where C is the rotary airlock valve capacity in cubic meter per revolution. R is the rate of conveying in tons per hour. D is the product density in kilogram per cubic meter. A is the valve efficiency in percent. S is the rotor speed in RPM. Next, we learn about how to calculate the capacity of the rotary airlock valve. The following equation is used to calculate the rotary airlock valve capacity. Rotary airlock valve capacity C is equal to R divided by D, then A divided by 100, and finally results divided by S. To calculate the rotary airlock valve capacity, divide the rate of conveying by the product density, then divide the result by the valve efficiency, and finally divide that result by the rotor speed. Given data, where C is the rotary airlock valve capacity M3 revolution. R is the rate of conveying 10 TPH 0.167 ton per minute. D is the product density 500 kilograms per cubic meter 0.5 ton per cubic meter. A is the valve efficiency 80%. S is the rotor speed 20 revolutions per minute. Please refer to the step-by-step calculation for better understanding. Based on equation and given data, rotary airlock valve capacity C equals 0.0201 cubic meter per revolution. Next, we learn about how to calculate the sizing of the rotary airlock valve. The volume, V, of a cylinder is given by V equals pi r squared h, where r is radius and h is the width. Please refer to the snaps, typical for rotary airlock valve width, h, is equal to diameter, d. So, updated formula is the rotary airlock capacity V equals pi multiplied by d divided by 2 whole square and multiplied by d. Given and obtained data as per previous slide calculation, the rotary airlock capacity V equals 0.0201 cubic meters per revolution. We get the diameter, d, solving as follow as. Please refer to the step-by-step calculation for better understanding. Based on equation and given data, rotary airlock valve size diameter, d equals 0.295 meters or d equals 300 millimeters.
So, 300 millimeters diameter of the rotary valve to be selected for handling the obtained volume of the dust load.
I hope everyone learns about the rotary airlock valve, the working principle of the rotary airlock valve, the function of the rotary airlock valve, and learned the capacity calculation and sizing of the rotary airlock valve. Thanks for watching. Subscribe to the channel for more videos.